concept. This is arc length. I don't know why it's tweaking out about it. It's looking not that bad. But basically, for arc length, you really just need to like know this equation, or like this equation. Like this equation is also written as beautiful. Wow. So this is y derivative squared, and then yeah. So this is like what I'm going to be using to explain it because it's like easier like that. But yeah, this is basically what you need to know. Arc length is like, so you're gonna have like a graph, right? Say this is our graph, and there's 2 points from here to here. This is basically like trying to figure out how long the curve is. So like imagine like a string like this, like a string, and then basically we're gonna straighten out the string, like straighten it out, and then find the length like that. So that's basically the concept of this. So not that bad, right? So we can start. I'm in a blue mood today, so we're gonna use blue. Blue just in general, like no deeper meaning. I just like the color blue. Okay. Anyways, so the question says find the distance between the points. These points. Okay. So yeah. So say this is 3. This is 8. Not like to scale, but who cares, man? It's not IB math. So our first point is gonna be right here. This is 3, 4. And then our next point, 8, 2, is gonna be right here. So find the distance. So we can assume it's gonna be a straight line, which I'm trying my best to draw. There you go. So twin, think about it. How do you think we're gonna find this, right? I'm gonna give you 30 seconds. 3, 2, 1. If you said the distance formula, you would be correct. Or, I mean, yeah, because this is a triangle, right? So like a squared plus b squared equals c squared. That. So then distance formula. Beautiful handwriting. This is just like the basic concept. Like this question won't be on the test, but it's just like for your understanding. Say like this is x, this is y right here. So then if we plug in the numbers, right, the difference of the x's is a minus 3 squared plus difference of the y, so it's just going to be 4 and 2. Oh, sorry, 2 and 4, because that's the order. My bad, because it's 3, 4, 3, 2. We started with 8, so it's going to be 8, 2, and then 3, 4. Don't make that mistake, twin. You do the thing, so that's 5 squared, just 25 plus, that's 2 squared, 92 squared. So that's going to be 4, so that's going to be equal to square root of 29. So if the question was like this, that would be the answer. But yeah, that's basically the concept. But like, unfortunately, all of them would not be, or not going to be like straight lines. Like this one, for example, you're looking at this and you're like, that's probably not a straight line, right? So I'll show you how to do that, twin. You don't need to know what the graph looks like, because we have this formula right here. Yeah, these formulas up here. So I'm gonna. Okay, so for this concept, you need to. It's basically just like taking the derivative of something and then taking the integral of that. So first step, just taking the derivative because we're trying to get to this equation, right? Or I guess this equation, right? So we're trying to find y, the derivative of y, and then when we get into this like format, we plug it into the integral and then take the bounds and stuff. So I'll write the thing. So L equals. So it's 1 plus y derivative squared, right? So that's what we're looking for. So we have y right here, right? So then y derivative. Think about it, twin. I'm gonna give you like a second to do the derivative, so I know you haven't forgotten, twin. Okay, so this right here. Have you done it? Okay, so remember for this, keep it constant and then multiply it by the exponent, and then minus 1 for the exponent. So something like that. And then this is just like there's no like variable, so that just disappears, right? So this is our new this is our derivative, but we want to get it like this, right? So it's derivative squared. So now we square this. So, well, you look at this, right? 2/3 over 3 over 2, that cancels out, so we just ignore that. So now we have x to the 1/2, which is also the square root of x squared, which is just x, right? So now, then we gotta get it like this, right? So square root 1 plus, instead of y derivative squared, we know it's x, so we just put x here. So then this is what we're gonna plug into the integral, right? So integral, let's plug into 0. So, right? So this is our thing, and then what are our bounds, right? So we have x equals 0 and x equals 3, so that's gonna be our bounds. That's a 0, not a 6. La 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 la. Okay. Now how do you derive this, twin? Twin? Are you awake? Twin? Wake up, twin. I'm calling on you, twin. When I say derive, I meant to integral this. Okay. 3, 2, 1. I hope you have your answer. Pause the video if not. But you know, this is also the same thing as this. And then when you integrate that, you can just plus 1 divided by the new fraction. So, or by the new exponent. So this would be. Wow, my mouse is tweaking out a little bit. Sorry. So just 3 over 2, and then divided by 3 over 2, which would just keep changing flips. So you can just give me 2 over 3. And then bounds from 3 over 0. Wow, I did not leave myself a lot of space for this. Okay, so yeah, I'll just do it right here like this. So we have, so the whole thing's, well, I'll do it down here actually. So the whole thing's going to be times this, so you can just do that, so then plug in the 3, right? So we have 1 minus 3, what am I saying? That's negative 2. Whoa, wait a minute, sorry, this is a plus sign. Sorry, I've been looking at this, I was like, where did the negative come from? No, I'm just stupid twin. Okay, so 1 plus 3, 4 to 3 over 2, minus 1 plus 0, so that's 1 to 3 over 2. So now we have, this is also rewritten as this, right? So then that's also equal to 16 times 2 is 4, 4, 6, 8. 8, and then this is just 1, right? So then this is going to be equal to 2 times 3 times 7 over 1, right? So then now this is 14 over 3, and that's going to be your answer. Yep, I'll let you look at that for a second. I hope that makes sense. Okay, you see, it's not that hard. Hi twin, ignore this. This is not a failed attempt. Don't close your eyes for a second, okay? Wow, I just messed up. How's your day? Good. So how's it good? Yeah, I know. Yeah, great. Last time. That's why. Ooh, no more. Okay. Back to this. So this question is just like this one. We want to get it into this form right here. So I'm gonna rewrite it for our just like easier to look at. So if A, B. Right, great. So we're looking for a derivative of y. So we have y right here. So take the derivative of this. If you do the derivative, possibly don't do it just so like you remember how to do it. But plus this. So derivative of this is going to be just in case you're confused how to take the derivative of this, I'll quickly explain it. So we have this, right? So then this is also equal to 1/2, and then x minus 1 when you bring it up, so this makes it easier to work with. So then you it times by the current exponent, which is -1, and then you minus 1 from the exponent, so it's going to be -2. So then that's negative 1/2, bring the x back down, stuff like that. So just a quick explanation, just in case you're confused. Because I don't want you to be confused, twin, don't be confused. Twin, stop being confused. No, sorry. Okay. Moving on, next step is to square it, right? So square this. But you're looking at this and it looks like a little like, we can simplify this, right? You're looking at it, so, because like 3 over 6, you can just simplify that to 1/2. So to make it easier to look at, minus 1/2 squared. So ignore this for right now. Right, and then, as I like kind of said before, that this whole topic is just like simplifying things or like making stuff, manipulating like this stuff to make it easier to work with. So in this case, we can make it like even easier, right? So take a wild guess. What can we do? If you said we could take out 1/2 from both terms, you would be correct. So we could also rewrite this as 1/2 times x squared minus 1 over x squared, right? So then now this would be easier for the next step, which I will do in a different color just for fun. Wow, beautiful. For the square for the next step. So square it. 1 over 2 squared is just 1/4. So then do this. It would be parentheses times parentheses, right? So middle term. Okay. This is like a little shortcut because you can see that these two terms are reciprocals of each other, right? Which means like for any reciprocal and you have and it's squared, the middle term is always going to be 2, and the negative depends on whatever it is. So if this was say a plus sign instead, it would be x4 plus 2 plus 1 over x4. But since it's negative, that's going to change the middle to be negative. And you'd be like, why is it just 2? I'll just work it out for you. If you like work it out, I'll do the color. So this times this, right, is x4, and then this times this, minus x squared over x squared, right, and then this and this minus x squared over x squared, and then this and this plus 1 over x4, and then these, since they like cancel out, it's just negative 1s, right, so this is negative 2, right, just like a quick little explanation there. Yeah. Okay, so we have this now, right, then the next step is to put a 1 plus in front of it, right, 1 plus, and since it's 1 plus and then this, right, we can kind of see that this, since it's just like a number, will combine with this. So when we do this step, to make it easier on us, wow, that's a 2. 1 plus, we can like factor out the 1/4. So it's like back in, so we can like combine like terms, right? So this would be, sorry. Suddenly I cannot do math or use my mouse. This is x. Oh, beautiful x. Oh my goodness. So then 1/4 plus -2, that's -1/2, and then plus 4x4, right? So then Yeah, I mean, you can take it with parentheses into that these two combine into positive 1/2 plus, right. So then the next step is to put in a square root, right? But if you look at this, you can make it like easier to look at, right? Which is the whole like topic. It's just manipulating your equation to just be easier to work with. So I'll give you a hint. We're going to be taking stuff out. So in this, we're going to be taking out the 1/4 right back out. So we have x4, then plus 2, then plus 1 over x4. So and it like kind of serves like as a little check. Like this, your answer right here should look similar to this. Like they look identical except for the like the positive sign, right? So it's like a little check to make sure it looks like you haven't done anything like extremely wrong when it comes to math. So and then you can go another step further to make this to simplify, because we're gonna take, because the whole thing is that we're putting this equation right here that we're trying to find under a square root, right? So it would be easier on us to make whatever this equation is squared, right? So when we do the square root, it just all disappears, right? That's like the goal. So how do we make this have a square root on the outside, right? Well, 1/4, that's easy, right? That's just 1/2, and then we're looking at this, right? And does this look similar to anything? I hope so, because this is what we did when we expanded this, right? So we kind of do the opposite now. So now we have x squared. And see, this is minus, so I went to minus here. And since this is plus, we put a plus sign. Middle term disappears. And we have this square root, right? I mean, sorry, squared. And then when we put in the thing, when we to this thing, right? We put it in a square root. So do the interval now. So what's our bounds, right? We have this point to this point. Okay. So what are our bounds? I'll give you 3 seconds to think. Go ahead. 3, 2, 1. If you said 1 and 2, you would be correct, because bounds are x's, right? So even though the y's look scary, it's just like bullshit, right? So 1, 2, do the square root of this thing right here, which is this. So 2, and then because we did it in a square thing, it just all disappears, right? So now we just have this thing, and then you can take out the thing. So I can take this out, and then all we have left is x squared. Sorry, I forgot dx. Don't crucify dx, right? Perfect. So then take the integral of this, and then that's going to be 3 over 3 plus, well, you bring it the -2 up, so then it's going to be negative 1 over x, bounds from 2 to 1. Again, I did not leave myself much space, but that's okay. So the whole thing is going to be times this, so then I'm going to plug it in. So 2 times 2 times 2, that's going to be 8/3 minus 1/2, then minus with 1, so that's 1/3 minus 1. So this is 8 over 3, right? And then negative 1/2, and then this turns into plus 1, so then that turns into plus 1/2. And then we also have a minus 1/3, which we can combine with this, right? So then that's going to turn into 7 over 3 plus 1/2. And then you just simplify this shit. So then this times this, I'm going to put it up here. So that's going to be 7 over 6 plus 1/4. And then get the same denominator, so that's going to be 28 over 24 plus 6 over 4, which is going to be equal to, oh, we're going to go up again. Oh, 34, 24, which simplifies to 17 over 12 divided by each by 2. And then that's your answer. Oh, thank God it's over. So it's like a long process here. I'll let you pause the video so you can look at the work. It's a long process, but like it's not too hard. I'll do one more example just to make sure you understand it. Okay, so last example. Okay, let's do the orange. So it's the same equation. A to B. You should have this memorized because they don't give us this with other things. For the McLaren series they give us, but this no. So memorize this one. Memorize it right now. Okay, so this we're looking for same steps. Looking for get rid of y. So change the thing. Wow, beautiful. Times exponent, right? And then minus 1 from the exponent. And remember, since it's a thing, the chain rule, right? So then times it by the inside, which is going to be 2x. So simplify a little bit, right? So we see this cancels out. So our new equation is going to be, well, square root, because this is all square root, right? So 2x plus 1 times 2x, right? So then our next step will be squaring this, right? And well, this is like relatively easy to square, right? Because this is square right here, so that goes away. So it's x squared plus 1, and then you square this, which turns into 4x squared, right? And you can also like distribute, right? So make it easier to look at. We have 4x to the 4th plus 4x squared. And now we do the next step, so we add the 1, right? So 1 plus, and then derivative. So we plus 1 to this. And now you're thinking, like, can we manipulate this further, right? So I'm going to ask you, Twin, can we manipulate this further to make it easier to work with? If you answered no, you'll be wrong, because we can. And you know how, Twin? I'm going to give you a second to think about it. You do like this thing again, right? You can turn this into a square, so what does what would equals this, right? Well, the answer is 2x squared, because it's 4 plus 1 squared, so yeah, just trial and error, Twin. Just keep throwing shit into the parentheses until you get your answer. So then, next up is you put it into the interval, which I will change colors for. A and B, well, good, it tells us what the bounds are. Square root of this thing right here. It's like, oh, thank God we put it in a square, right? Because it makes it easier to work with. So, thing disappears. 2x plus 1. I just straight up forgot to draw the integral thing. My bad. There you go. Can you read that? I'm just like now realizing how messy my handwriting is. Sorry. I'll write a little bit slower. Okay. So now you take the integral of this, right? Not too bad. Right. So then do the thing. So 2 times. That's a 3, by the way. Plus 3 minus. Well, this is gonna be 0. Plus 0. So just ignore this part. So then 3 times 2 times 8 times 2. So that's 2 times 27. So it's 27. It's 54. So 54 over 3 plus 3, right? Plus 3. Well, let's see. 54 is divisible by 3, right? So then that's 18 plus 3, which is going to equal to 21, and this is our answer. Yippee! Okay, I'll let you look at that for a second. So yeah, arc length, not too bad. You just gotta memorize the like formula thing, and then just like thunk real hard about how to manipulate the whatever equation you have to fit that thing. So yep, that's all, Twin. Let me know if you have any questions, Twin, or don't. Yep, that's it. Bye, Twin.